Good morning, Suzuki Science, grade 11s. Okay, the evidence for evolution lesson. It's an activity. Normally the lesson itself is really short. And in a normal year, I'd give you 2 periods to work on this in class, and then you'd have time at home to work on this. So this will mesh very nicely with our current schedule of what we're trying to do here in evolution. So I do want to give you a little bit of a preamble though. Okay, so we are learning about evolution, and one of the reasons why we talk so much about evolution is because there is some evidence that has existed in our history, in our current world, that shows that something existed on this planet that's not the same as it is now. Okay, so we are going to look at the evidence that supports evolution. Now, before I get there, I want you to think about what examples exist today that show that you exist. So if I were to go into tomorrow and I was looking yesterday, what evidence exists? And so at this point, you'd all be kind of sharing ideas, and you'd throw out certain things, and you probably wouldn't shout out dirty laundry, but that's a possibility, and emails, and photos, and drawings, trash, things in your locker, if we were using lockers. Suppose we fast forwarded a year, you graduated in 2 years, and you came back for, a reunion. What evidence exists that shows that you existed at Suzuki, right? The prom picture, the diploma. If we advance a couple of decades and you come back for the 25th anniversary reunion from your grad, or if we fast forward 100 years, what evidence would exist? So think about this in terms of a dinosaur hunt or something paleontological. So you're looking at something from thousands or hundreds of thousands or millions of years ago. And now you start to see the problems that we are looking at when we're trying to find the evidence for evolution, an event that has occurred over a very long period of time. So we need to know what evolution is. So this is a key definition. So in this evidence for evolution lesson, one of the key takeaways is this. What is evolution? In the books, you'll often see something called descent with modification. It's kind of a fancy way of saying changing over time. But you have to be very careful when we talk about change. We're not talking about leaves falling off a tree or a mountain eroding. We're talking about how an organism will change based on the environment so that it's better suited for living under those conditions. Now, in terms of evolution, there are 2 big terms, micro and macro. We're going to focus a lot on micro in this course. So that is looking at how something like an Arctic hare will go from white to dark. And in the snow, the white Arctic hare is going to be more prevalent because it hides better, and a snowy owl won't see it very well. They'll pick up the brown ones. And so the variation in the population will be reduced because the brown Arctic hares will be picked off and the white Arctic hares will reproduce. Macroevolution is a brand new species. So that's where you go from an Arctic hare into a jackrabbit and into some other kind of hare. 2 unique species. So the development of a new species is macroevolution. All right. Normally at this point, and I'll do this in class, I'll show you another video and I talk more about the definition of evolution. But in this course, we are under the premise that all life comes from a common ancestor, some kind of cell. And over a period of 4.5 billion years, our cell has changed. And it has changed from a single cell organism into a eukaryotic cell, into protist, and so on and so on. So as you go through the activity, one of the things you're going to get to explore are evidence that supports evolution occurred. And when we take a look at mammals, for example, well, we know that mammals have evolved to live on land. However, there are quite a few mammals that live in water. Seals, whales, for example. So if mammals evolved to live on land, how did they end up back in the water? So that's something worth exploring, and you'll see that in the activity that you're going to go through, and you'll watch a few videos and you'll get a better understanding of how the whole process worked. So here is the evidence for evolution. It comes in 5 categories. We have fossil evidence, which is a very interesting story in itself, and under better conditions, I would have talked about the bone wars between these 2 scientists, and it's totally fascinating. I think they're going to make a HBO special about it, but then one of the main actors who was going to play one of the protagonists died, and so they scrapped that. But the bones, I mean, if we back up about 300 or 100 years or so, people didn't know about dinosaurs. Not really. They knew there were some bones in the ground, but they didn't try putting them together. And the first time they started putting them together, they made all sorts of mistakes because they assumed it was an animal that existed. And then when they started realizing that these were animals that don't exist anymore, they'd take the tail and put a head on top of the tail, and like, hey, that doesn't make sense. But hey, we've never seen this before, and so on and so on. If we had a regular year, we go to the ROM, and if you have, for those of you who've not seen fossils, we would have an opportunity to see it for the first time. Biogeography, molecular evidence, comparative anatomy, and comparative embryology. These are the 5 evidences for evolution that you should be familiar with in this course. So you're going to go through the PowerPoint, and in the PowerPoint, I've given you some key highlights for each of the evidence. You'll click on the videos if there's links and watch the videos. You don't have to watch the whole thing. Watch it the first couple minutes, and if you really enjoy it, then watch the whole thing. And that will give you more information about fossils and living fossils. You'll learn more about anatomy and important terms. You'll notice there's no definitions here. These are key terms that you should know. And then you'll do work throughout the activity to give it more meaning. We used to call it comparative embryology, but a more contemporary term is evo-devo, evolutionary developmental biology. And so we look at how an organism develops through its evolutionary stages. There is a lot of misconceptions associated with evolution. And one of the misconceptions that stood the test of times is this phrase that says, ontogeny recapitulates phylogeny. And you'll explore that statement and what it means and why it's wrong in the activity. Okay? If I gave you this little fetus here, and I told you what is it, for most of you, you would not be able to tell if it's a pig, a shark, a human, a dog, because at this very young age, they all look very similar. Biogeography, another evidence for evolution. You'll see a couple of scientist names here, and you'll see key terms that help you focus on the definition that I want you to have for biogeography. And of course, the latest, newest evidence for evolution, but it's not that new, it's older than you are, but in the grand scheme of fossils and biogeography, it's a relatively new science. And in this one, we're looking at the DNA. And we know that for an organism that shares more DNA with another one, the more closely they're related in the evolutionary timescale. So if we take 2 organisms and they share 99.9% of the DNA, and you take another organism and it shares 99.4% of its DNA, you know the ones that have 99.9% of the DNA have a more common recent ancestor, for example. So molecular evidence is a really good piece of evidence that we use for building relationship trees known as phylograms, phylogenetic trees, cladograms. I'll teach that later. Okay, so if you take a look at this chart here, you'll see this chart is read 1 to 59, and it starts at 60 to 112. So when you're reading across the rhesus monkey here, you're going to go GD all the way to AA, and you're going to keep on going, NK, NK, all the way to NE. In this chart, the way you read it is in the activity, you're going to be comparing various organisms to the human. So here's the humans. This is an amino acid sequence. We haven't really talked about the biochemistry of these important molecules. We'll talk more about that in grade 12, but it's enough to know that amino acids are the building blocks of protein, and proteins make up the majority of the dry matter inside your body. So there's one particular protein in a mitochondria that makes up a cytochrome. It's part of the respiratory complex, and it's conserved. That means it mutates very little over the millions of years of life. So because it mutates so little, we can use it to determine how closely related very distant organisms are from each other, because there's minimal mutation. So if I want to see how closely the rhesus monkey and the horse are, I'm going to look at this particular cytochrome, and I'm going to go across until I see a difference. So as I go across, you'll notice the first difference occurs right here at number 19. The rhesus monkey has an I at 19, and the horse has a V. So that's one difference. And there's another difference here at 20, M and Q. And I keep on going until I get all the way to the end, and then I just keep on going on the second line. And by the time it's all said and done, I might notice that there is 7 differences between a rhesus monkey and a horse. And if I compare a rhesus monkey and a gray whale, I might see 13 differences. And so those 13 differences tells me that there is a greater, there's a much more distant ancestor between the rhesus monkey and the gray whale than there is between a rhesus monkey and a horse. So that's what this diagram is all about. Okay. I did go to the Smithsonian. I've been there several times. If you ever have an opportunity, it's this massive complex of museums in Washington, D.C. You're not going to go anytime soon. Clearly, it's on the other side of the border. You don't want to go to the States at the moment. But this is an amazing museum, and it's free, even though we're not American citizens. So you can go in there, and they have this fantastic collection of everything. And one of the last times I went there was in 2018, and they have this very interesting hominid collection. So they show these hominids. Here's Paranthropus. Here is Australopithecus afarensis, another Australopithecus, Homo erectus, Homo neanderthalis, Homo heidelbergensis, Homo florensis, which is its own little thing. This is called like a hobbit or something like that. It lives on a little island. And of course, we're Homo sapiens. There are many different hominids. And in the activity, you're going to explore some of the various hominids. There was a period of time when there were several different hominids on a planet at the same time. Kind of like there's, a group of different squirrels and a group of different lions. So there's different Homo genus species different species of the Homo genus. So we're able to take a look at that cytochrome that I was talking about, and we could follow that cytochrome in humans, in Homo sapiens, and we could see the relatedness of humans, Homo sapiens, to each other, and trace our ancestry back to a common point in Africa. This is known as the out of Africa hypothesis, because we weren't around to observe and make notes about what happened all these years ago. So it is a hypothesis, but there's a lot of really good evidence to support this. And different hypotheses support the idea that the hominids left Africa several times. And each time they left, they basically wiped out another species of hominids, as the Homo sapiens was the most successful for whatever reason. Right? So that's what this out of Africa hypothesis explores. And you'll see in the activity that I ask you a question about it. I give you several different graphics for it. Okay? And if we take a look at the brain case of the hominids, you'll notice as I show you the pictures, but the actual skull that holds the brain, and the brain which kind of determines the upper potential of our intelligence, you'll notice that as you go up here, the Homo sapiens has the largest brain case. Okay? And with that intelligence came obviously the ability to outcompete our competitors, and we're now the only existing hominids on the planet. There are some really interesting hypotheses as to why we were successful, and once again, in the interest of time, I'm not going to include it in this PowerPoint. As I said, I was keeping this relatively short. Really, what I wanted to do is I wanted to go over with you the expectations of the activity. So you're responsible for doing this evidence for evolution. And you'll notice that there's different ways to get marks. If you complete basically the minimum, you're taking this as an elective, so I assume you're all going to do the minimum, then that will be a level 3. If you complete all the minimum plus the nice to complete, then you can max out at an 85%, a level 4. And if you do all the level 3 and level 4 stuff, the nice to complete, and the microbiome activity, then you can max out at 100%. Okay, so there are a number of pieces to this. So the evidence for evolution you'll find within D2L, and as you scroll through, you'll have to open the file completely as a Word file, and I'll put it as a Google Doc as well, just in case the links aren't working and you guys don't have Microsoft Word. And each of these links sends you somewhere. And most of the cases, they're animations, they're simulations, they're things that will get you a better appreciation for evolution. So this first one, for example, I'll just let it load here. When you click on this link, you'll see something like this. So I'm going to skip the intro. That's called the riddle of the bones. And so you find these bones, you're trying to put them together to get an understanding of what some of the early hominids look like, and how the scientists were able to determine what they determined. So there's a lot of activities where you're clicking on links and it's sending you to simulations, animations, and resources. Okay? So anything in red is the important to complete. You complete the important to complete and you do it well, you'll max out at a level 3, which is a 73. If you do the nice to complete, then you can max out at a level 4. Okay? So it depends on how much time you want to invest on this. And you don't automatically get a level 4. You have to answer it well. Okay. So here's the biogeography piece. You'll see the red, which is the important to complete. The nice to complete is green. These maps are associated with it. Comparative anatomy. The red is the important to complete. The green is the nice to complete. Comparative embryology. Same thing. More links. Sometimes when you click on it, I think it's this one right here. If you click on it and you run it through Internet Explorer, any of the really modern browsers, it won't work. So you have to use a browser like Pale Moon, or there's some other browsers out there which will allow it to work. I did do a whole bunch of screenshots and I put them into a folder in D2L, and you can access that to get the screenshots in case you can't get it to work, and then you can still answer the questions. Okay. And then nice to complete, Evo Devo, I kind of mentioned that. Nice to complete, summary of evidence. This is an important thing to complete if you want to do the final activity. Putting Darwin on the map is a nice to complete. So you're going to map Darwin's, you're going to trace his journey from where he started and around the world, because he's the one who gave us the theory of evolution. And he did this through incredible observation. And he's a very interesting scientist. Again, sadly, I haven't had the time to really explore Darwin with you, but maybe we will. We'll see how the next couple of weeks plans out. Okay, and then level 4, plus, you are going to complete the microbio activity and the putting Darwin on the map. The microbio activity is right here at the end, and I showed you how to read that cladogram, and so that's where you're going to put these differences, the amino acid differences, answer these questions. When you're answering these questions, if you have an opportunity to use answers from previous questions, do so. That will give you a higher level. It'll demonstrate a really good understanding of the concept. Okay, so that is the activity, evidence for evolution. So to fully explain it, you go to our content or our calendar. I'm not sure I put it on the calendar yet, so I'm going to go to content. And then you're going to go to evolution. And under evolution, you'll see something that's called evidence for evolution. Evidence for evolution. And in here, you'll see the evidence for evolution note. So that's the PowerPoint. You'll see the evidence for evolution assignment. And then anytime you're given a link, if you click on a link and it doesn't work, come here to D2L. Under additional resources, this is where everything is. The whale data table, whale in the making, whale walking in the past, the continental drift. There's a fossil coordinate activity. You'll have to print it out, and then you can either print it out and then cut it out and move it around, or it's a Word document and you can move the horses, they're fossilized horses, and put them in the correct order. The Americas, I put in the activity so you don't have to open this up. But if you ever are looking for a resource and you can't find it, come here first, and you should find it in this resource area. Here's the microbiology activity, which is separate if you want, or you can find it in the main document that I put it in, and you're submitting it here. Evidence for evolution Dropbox or evidence for evolution microbio, and that's where you submit your work. All right, so you'll have until next Tuesday to complete it. You can work with a partner, that's perfectly fine. Okay, so this is something that will count for marks, and if you have any questions as you're working through it and you need help, you can ask me, and I'll at least give you directions so that you're not completely confused. All right, if you work through the instructions, it should be pretty self-explanatory. Cohort A, Cohort B, it doesn't matter what class you're part of, you can work with anybody you like. And that's it.